One of the things that we do here to try to make sure that we get a lot of agency folks to show up is to make it easy for them to come. You know, all you got to do is find some money for gas and get yourself here. You know, we pay for everything, and we're gonna have a nice light breakfast in a little while and a nice lunch. So anyway, that requires quite a bit of money, and I'd like to thank FWC, who contributes to the event, and also the Everglades Foundation. They've contributed to the event for 4 years now with a nice size grant. So it helps to make these things possible. And GNU Manufacturing also donates a GNU that we raffle every year, and we make a pretty good bit of money off of that as well. So I'd like to thank those sponsors for sticking with us. You ready? Okay.
Yeah, I'm not going to say a whole lot other than thank you for coming out. This is my first one that I've actually had to help put together, but I want to thank John Hitchcock because he did most of the heavy lifting on it this time, which is probably good that we had one experienced person doing this with somebody that was learning the ropes. I didn't realize how much effort went into putting this thing together, but Hitch has done a really good job of putting most of this together. So I just want to thank you for that. Okay, and you know, thanks for everybody who came to the cookout last night, and you know, we had a lot of good chats going on, and that's always a good time. I think we're just going to go ahead and get started. So our MC for the day is our new waterfowl and small game biologist for Central and South Florida. He's our new guy, and I figured I would give him baptism by fire and make him stand up here and talk in front of you guys for the rest of the day. So that's Mark McBride, and he's going to be our MC for the day. And if you've got any questions throughout the day, I guess the way we're going to do it is let's let the presentations go forward, and we'll get questions at the end. Remember that we have a panel discussion at the end of the day, so if you think of questions afterwards, you can certainly get those questions in the panel box so that we can have some good discussion at the end of the presentations. But feel free, grill these folks that are up here, ask your questions, and they think that they'll be happy to answer your questions. So we're going to go ahead and get started.
Thanks for having me back. It's always a pleasure to be here and to talk about one of the most favorite subjects I love talking about, and this is dealing with waterfowl and habitat management issues. As some of you may know, in the past I've talked about the waterfowl food web, and I think the first presentation dealt with the waterfowl food web of freshwater marshes, and that was followed up by the waterfowl food web of lakes and aquatic systems. And the third presentation was dealing with the waterfowl food web of brackish and estuary and salt marshes. This time what I'm going to kind of do is wrap it all up and package it all together and talk about some of the habitat issues associated with freshwater wetlands. For the purposes of this presentation, I've broken it down into three main components. I'm going to do a quick review of the energetic requirements that waterfowl need. I'm going to follow that up and talk about some of the basic biological planning dealing with plant issues and botany issues. And then we're going to wrap up and then talk a little bit about some habitat management considerations. If we look at this slide here and this value here, does this have a pointer on it? Maybe that's a pointer. There it is. Basic metabolic rate. We know that based on waterfowl studies that the basic metabolic rate for a resting waterfowl is 292 kilocalories per day. And just so you know, 1 kilocalorie is equal to 1 calorie. It's no different than our diet, when our anticipated diet is based on about 2,000 or 2,500 calories per day. Waterfowl, we know, is 292 kilocalories, and this is, again, basic metabolic rate. This is basic bodily function. It doesn't take into consideration thermal regulation or courtship or preening or going out and searching for food. Waterfowl diet consists of two primarily food groups. The first of these are proteins. We know that proteins are primarily an early summer diet of waterfowl, early spring summer diet of waterfowl. Waterfowl are focusing in on crustaceans, gastropods, pelecypods, and various aquatic insects. Some of the more common proteins in the diet of waterfowl are listed here, and you can see that they really don't have a huge gross energy value. And keep in mind that when waterfowl are consuming on proteins, they're really targeting specific components of their diet. We know that proteins are important for brood rearing. Proteins are also important for egg laying and production of eggs. It's also important for bodily tissue and muscle development as well. The second component of their diet is carbohydrates. Carbohydrates represent highly rich metabolized energy for waterfowl. And we talk about carbohydrates, we're really talking about all vegetative matter, whether it's seeds, whether it's tubers, whether it's stems, leaf material. And this also includes waste grains as well. We know that up to during the wintering period that about 90% of a puddle duck's diet consists of carbohydrates. So this is a very, very important component of the diet for waterfowl, particularly for us here in Florida, because we know that majority of the birds are wintering and migrating through Florida at this time. So here's a list of some of the common annual seed producing plants and some of the more common waste grains that we see, and if you recall that these gross energy values are much, much higher than those protein values. We also know that there's a difference between gross energy and what we refer to as true metabolized energy, and the difference is basically that which is consumed by the duck and actually used by the duck, and the difference being excreted as waste. So this is, again, it's based on feeding studies where they feed a specific diet, a specific amount of food to waterfowl, and they measure the inputs and they measure the outputs. And again, true metabolized energy is what is actually utilized, and gross energy is the difference being excreted as waste. And we talk about managing wetlands, and a lot of the emphasis here has always been on waterfowl, but there's something else I wanted to key in on and spend a few minutes talking about, and this is shorebirds. We really don't hear a lot about shorebirds, and shorebirds are kind of unique and different in that shorebirds are kind of pre-genetically programmed to stop at these major feeding areas. We know that they're circumpolar navigators, many of them are, and they leave the Arctic nesting grounds. And they have these major staging areas that they stop and feed at during their migration. What's kind of unique about shorebirds, unlike waterfowl, who tend to be these opportunistic feeders, they'll go out and find food everywhere, but shorebirds are kind of, like I said, they're programmed to stop and feed at these major staging areas. And what's really critical is that we've known that shorebird populations, we've seen dramatic declines in shorebird populations. And much of this is due to a loss of habitat or alterations of those habitat types. And the thing about shorebirds is when they stop and feed at a staging area, they'll stay there for about 2 weeks and they'll just double their body weight. They'll feed solid for about 10 days straight. And in fact, they consume so much food, they get so fat they can't even fly. And they just kind of shut down for about 2 or 3 days. Well, during that time period, their bodily organs are also doubling in size, and they're doing everything they can to process all this food and this energy. And you may have noticed this before, walking on the beach and you see a pod of shorebirds or a group of shorebirds, and they're not moving. They're just kind of sitting there doing their shorebird thing, you know. And it's because what they're doing is they're digesting their food. They go into this digestive coma. And after about 2 or 3 days, after the organs process all this energy, it gives them enough energy to get up and fly to the next staging area. Well, if that staging area is out of production or if that staging area has been converted, these guys don't know enough to go find food elsewhere. They'll continue flying to the next staging area. And oftentimes what happens is they arrive, they're weak, they're malnourished, and they fall easy to prey. So when we think about shorebirds and we think about habitat and wetlands, keep these things in mind about managing these kind of systems and We talk about the diet of shorebirds. We're fortunate in that in Florida we have long growing season. The primary component of a diet for shorebirds is insects. And what do insects need in these wetlands? They need dead decaying plant material. If you got a lot of dead vegetation or dying plant biomass in your marsh, that's good because that serves as an attractant. That allows for colonization by insects, and you'll get tons of insects in there. You've got shredders, you've got collectors, you've got filters, you've got grazers, you've got a variety of types. The most important of these are your fly larvae, or your midge larvae. Some people call them chironomid larvae, otherwise they're known as bloodworms. They are probably the most abundant macroinvertebrate in freshwater wetlands and isolated wetlands, moist soil impoundments. And what's kind of unique about these midge larvae is they're highly adaptable. They can survive. You need a puddle for them to lay eggs. And once they can get their eggs are laid, they can survive drought, they can survive extreme flooding, they can survive high salinities. So bloodworms, midge larvae, a major component of a shorebird's diet. Unfortunately, we don't have a lot of research that tells us what their basic metabolic rates and that kind of stuff is, and I wish I could share that with you, but I can't. So, that kind of wraps up that energetic component that we're talking about. So this kind of gives you an idea of what the needs are for wildlife, and now we're going to kind of get into this idea of about how to think about planning and how to go about meeting their needs. And before I get there, I wanted to touch in a little bit talk about some plant biology. Us waterfowl types, or us biologists, we tend to be introverts, you know. We tend to go out and spend our time in the woods or spend our time, and we get so consumed and so locked in on some specific avenue of research or some specific avenue of management that we kind of lose focus. And so what I like to do is go back, and when I work with staff or when I work with other folks like the USDA and Fish and Wildlife Service folks and thinking about wetland management activities, I like to introduce this kind of stuff that kind of brings us back and it kind of simplifies things. So when we talk about plant biology, we're going to talk about the basic element of process of photosynthesis. We all know that photosynthesis is a process where plants take up carbon dioxide and through this chemical process convert that into complex organic compounds, primarily sugars and carbohydrates. And during the fall and during the dormant season, those carbohydrates are Here we go. All of that stuff gets translocated down in the root system during the dormant season. It's pretty simple process. We all know this. But when we think about management and when we're wanting to manage these marshes, we all know that we're either targeting plants that we want to get rid of or targeting plants that we want to encourage. So if we think about this process of this translocation of nutrients down into the root system, or carbohydrates down into the root system, when these plants come out of dormancy, they pull all those carbohydrates up out of the system so they can produce that one leaf and start that little factory production again. So one of the things why chemicals, herbicides are so effective because they alter this process. There are management techniques that we can also utilize to help us in this endeavor as well. So when you think about disking or if you want to control some plants, you can wait until this growing season starts, wait till that plant pulls up all those energies to produce that new shoots. And if you can target or time your approach to that process, you can go in and disc those plants and hit them while their plants are at their weakest moment. Does that make sense? Is that clear to you guys? Anyhow, so this is some of the things that I want to emphasize here when we talk about plant biology and some of our planting techniques. Other things to keep in mind is plant phenology. When we talk about plant phenology, it's primarily the study of plants in relation to climatic conditions. This is another thing that tying into the carbohydrate cycle, the nutrient reserve cycle, is when plants go into flower. Oftentimes that requires a lot of energy and extra energy for that plant to produce those flowers. That's kind of a weak or a stress point of that plant. If you want to think about timing your techniques or timing your your management activities, consider doing it during the flowering period. So when we talk about plant phenology, it's knowing about the relationship of the climatic conditions and specific to the plants that you're targeting. Other things to keep in mind are whether or not you're dealing with monocots or dicots, or are you dealing with annuals or perennials. We know about the flowering season, but how does it flower? Is it through seeds? Is it through vegetative reproduction? So those things, keep in mind those things and understand those things and help use those things to your management techniques. So when we're dealing with freshwater marshes, our vegetative component primarily consists of moist soil and herbaceous annual seed producing plants. These are your annual grasses and your herbaceous plants. We know that annuals complete their life cycle in 1 year. They grow, they produce a seed, and then they die off. So as a result, and to maintain their existence, they tend to be very heavy, prolific seed producers. Conversely, your perennials can survive up to many years. They can typically, they produce a seed, they do vegetative reproduction. We also know that they tend to be a little bit more advanced in that they have erechma tissues and adventitious roots that allow them or enable them to survive under extreme drought or flooding conditions. Since we're talking about freshwater marshes, if you see a freshwater marsh or an isolated wetland, if you see it's dominated with perennials, you know something's wrong. Something is not right with the system. And most oftentimes this is due to a lack of disturbance. Excuse me, this could be caused by stable or high water levels. When you get high water levels or stabilized water levels, you shift more to this, you shift more to anaerobic changes, which leads to organic accumulation. You get nutrient enrichment, changes in chemistry. All of these things begin to factor and have an influence on your vegetative plants. Remember, we're trying to, the focus is on moist soil annual seed producing plants. We want annuals in these isolated wetlands. And that's not to say that we don't want perennials. A little diversity is good, but when your marsh gets predominated by perennials, you know something's not right. We need to get back in there and mix things up. Think about setting back plant succession. Here's some reasons why. Under lack of disturbance, you get lower seed production, you get increased perennials, more woody vegetation. That's not necessarily a good thing. If you look at your changes in seed production of a millet, your first year is 1,800 pounds to the acre. In the absence of disturbance, that production drops off to less than 500 pounds per acre. And doggone it, I forgot to mention something. This is important. I want to point this out. Earlier when we were talking about the energetic stuff, I told you basic metabolic rate was 292 kilocalories per day, right? And think about the math here. And if you remember the moist soil energy values for moist soil plants, that standard, that true metabolized value that we used was about 2.5 kilocalories. Well, if you divide 2.5 kilocalories into 292, that's 116 grams. So this right here is 116 grams. This is how much seed it takes to feed a basic mallard duck, basic metabolic requirements to get them through the day. All right, I'm going to just pass these around. That's a one-day deal. Now, if we think about migration, I don't know if I've touched in on migration. Might have been something else I forgot to mention about. So basic metabolic rate was 292 kilocalories. Basic metabolic rate again. When you think about migration, how much more energy is required? Estimates are that it takes 10 to 12 times that amount to get them through migration. It's like marathon runners, you know, you need a diet. Take that same value, multiply it by 10, and you get about 1.2 grams or kilos. This is how much their diet they need during migration when they're expending that much energy. That's a lot of seed. And when you think about this value up here, that's daily during migration. Now this is dry. You have to take in consideration when they're feeding, it's more wet and moist, so there's going to be some differences, but I think you get what I do with my... I think the point I'm trying to make here is in the lack of disturbance, when your seed production drops off to 500 pounds an acre and you're looking at these bags of seed, that's a lot of seed. That's a huge difference for waterfowl. So the flip side of that is looking at production of perennials. We know we have perennials like Phragmites, Typha, Nufar, And what you're seeing above ground here is 7,500 pounds to the acre. But what you're seeing below ground and what most people don't see is that's 16,000 pounds to the acre of carbohydrates, just production ready to explode on you. And these are the things that we have to keep in mind. These are the things that we have to watch out for. And this is why it's so important when we're dealing with freshwater marshes to think about your disturbance activity and keep it in an early successional stage. Because once you get to this stage of the game, it takes a lot of energy, it takes a lot of effort to set that back and to keep that under control so that you can go back to those 1,800 pounds per acre of seed production. So this kind of leads us into the third and final phase, is putting this all together and talking about some of the habitat management techniques. And before I go down there, I just wanted to touch in on, I'm often asked why we manage and what's the purpose of management. Can't you just go in there and restore a marsh and let nature do its thing? Well, I wish we could, and there are some cases where you can, but that's pretty rare and extreme these days. And we know that if we look at the North American landscape over the last 100 years, we know that over 70% of our freshwater wetlands have been altered, converted, or destroyed, impacted to some degree or another. This puts a lot of pressure on those wetlands that do exist. And when we think about all the subtle little chemical and physical changes that are occurring that we don't see, and then we start thinking about some of these biological issues that we don't think about. When you think about those shorebirds and how they rely on those major feeding areas to survive and to carry them through to the next staging area, you know, and we think about those seed productions and how to provide those food resources. It's like those wetlands are getting scrunched and smaller, but yet those biological issues are still there, and we still have to deal with those. So these are some of the things that we have to think about when we talk about habitat manage and why we manage and the importance of managing. And another point is you know, where's a wetland that you've gone to that hasn't been altered and that there's not a system of dikes and levees and canals, and we lose that sheet flow, and we've lost a lot of that. So that's another reason. I'll touch in on some of that a little bit more. So when we're dealing with challenges for management, we have disrupted hydrology, we have alterations to our topography. Of course, there's always the issues with exotics and invasive plants and natural disturbances. I'll put this up there. This is before I knew Mark was going to be introduced as the MC, but we're talking about altered hydrology. I don't know, he's wearing a lot of that on his face. This is Mark's first airboat ride. I think, where were we, on Lake Kissimmee or something? Anyhow, Mark is the new biologist. We all know that now, so thanks for stealing my thumbnail on that one. So habitat management considerations are broken down into four main components. We've got hydrology, mechanical disturbance, herbicide application, and control burning. I'm going to go in and talk a little bit about each one of these, beginning with hydrology. Hydrology, this is everything, this forms the basis of all our restoration activity. If you don't get the hydrology right, it's over with. This is the primary function. This is our number one thing when we're dealing with freshwater wetlands and isolated wetlands and trying to restore them. We got to get the hydrology right. For those of you who are into this, and if you have property and you're thinking about restoring that or wanting to know a little bit about your hydrology or wanting to know what your hydro period is, every county in this country has what they refer to as a soil survey. Everybody here familiar with soil surveys? You can pull up a soil survey and you can pinpoint your piece of property. It'll tell you what kind of soils you have. Generally, they break it down into two groups. Either you're hydric soils or non-hydric. If you're hydric soils, it'll tell you everything you need to know about your hydrology and what your hydro period is. It'll tell you rainfall amounts. It'll tell you on a monthly basis where that water table should be within your soils, whether it's 2 or 4 or 6 centimeters below the surface. If you have ponded soils or what we call flooded soils, floodplain soils, it'll tell you what the peaks should be. Like typically for South Florida, ponded soils, we know that they're flooded 2 to 4 or 2 to 6 inches or 1 to 2 feet above ground throughout the growing season or throughout the rainy season. Every county, everybody has access to a soil survey. You can also get it off the Web Soil Survey. It's a site online that's managed by the Natural Resources Conservation Service Web Soil Survey. It's a great access to this resource. So we've got to get the hydrology right. If we know we get the hydrology right, we're halfway there. Can we take it a step further and introduce water level manipulations? You bet. Having that ability to fluctuate and manipulate your water levels gives you that extra added security, gives you that extra benefit of ensuring that you're introducing this dynamic flooding, seasonal flooding and drying out of these wetlands. When we talked earlier about disturbance, the basis of all of that disturbance begins with that drying out of these periods. You know, the wetlands are unique in that they're not aquatic systems. Wetlands represent a transition between uplands and aquatic systems. Wetlands have to dry out. They need to dry out every year, especially these isolated wetlands. That is the basis of disturbance, and that is the basis of our water level manipulation, is being able to mimic the natural hydro period. And if we can do that through water level manipulation, that's all the better. When we're thinking about managing those plants and how do we manage for certain types of plants, we think about the timing, the speed, and the length of these drawdowns, followed by implementation of these techniques and reflooding. That process alone will dictate and influence the types of plants that respond and grow under the system. Another important element of water level management is knowing the bird responses and knowing how a bird reacts to these various water levels out there. Again, we're dealing with isolated wetlands. If there was a way that I could take a graph like this and overlay seasonal rainfall patterns, I'd love to be able to do that, because one of the beautiful things about being in Peninsula Florida, if we take a graph like this and we look at seasonal rainfall patterns and then we add to that the chronology of migration, that is the timing of migration. Florida, you know, in South Florida, our rainfall begins in June. And typically about the first 3 to 4 weeks of June, most of that water gets absorbed into the soil. We really don't start ponding water till maybe July, mid-July. Well, guess what? When do shorebirds start migrating through? Shorebirds start coming through about late July, early August, just about the time when that water starts ponding, and that gets us in this range. 70% of all shorebirds feed within this 4-inch continuum right here. As the rainy season progresses, water begins to build in these marshes, and we begin accumulating 8 to 12 inches. By the time we get into September, October, we get a few tropical storms, you know, things start picking up, and guess what? Here come waterfowl. Start migrating through beginning in September. Anyhow, so this kind of slide just kind of gives you another idea of how we can, by having that water level regulation, having those water control structures, and being able to help mimic those water levels to mimic the natural hydro period and to time it to coincide with the migration of these birds as they're coming through. All right, second thing I want to talk about is, in terms of habitat management, is some of your mechanical manipulations. And this include things like your disking. We've got heavy disc. This has got 2 primary disc blades or sets of blades that run along here. This is what we refer to as a heavy disc or an offset disc. When we look at the disking pattern and the environment, it tends to be very rough, tends to be very clumpy, as opposed to a finished disc where you've got 2 rows of disc here. You guys have seen this before. I don't really need to spend too much time on it. And another form of disking is a smoother, or what we refer to as a culture packer. If we look at the topography of these 3 disking techniques, up here is our heavy disc. This is a soil profile, finished disc, a little bit smoother in culture packing. Does this have an effect on vegetation and what you're trying to manage for? You bet. It does. We know that heavy disking, you tend to get a lot of dry, more upland species like your cockleburs, in particular, South Florida, dog fennel is a major issue with us. Whereas finished disc, you get more of your millets, and then in your culture packers, you're fine. It's more your grasses and your sedges. Here's the reason why. When you get that rough disking, you get this little microclimates within the soil, and up on your higher, drier clumps is where you're going to get your cockleburs or your dog fennels, and down low, this is where it tends to be a little bit moisture. You're going to get most of your moist soil annuals growing down in there. Other forms of mechanical disturbance include rotary mowing, sickle bar mowing, And I threw roller chopper in with this bunch because roller chopping has pretty much the same effect that mowing does. In fact, it has these long blades here, and you pull this behind a tractor in the marsh, and it basically cuts the plant off about 6 inches above the base. And it's a lot easier to pull a roller chopper through the marsh as opposed to trying to pull a batwing mower through the marsh. If any of you guys have done that, you know. A huge difference. When we think about mowing and its effects on vegetation, we have to keep in mind, getting back to some of this basic biological plant botany thing, is talking about your monocots and your dicots, and there are issues here with mowing, dealing with the growing tips here as on your dicots as opposed to your monocots here. And that's because of this tissue that we refer to as a meristematic tissue or the meristematic stem. This meristematic tissue kind of regulates the growth and development of these plants. And we know that on dicots, that meristematic tissue is located out on the edges of these branching nodes. This is, you know, for you guys who are into pruning rose bushes and things like that, when you clip it off, it tends to shoot out and break out and branch out from that. That's because of that meristematic stem. But we know on monocots, it's located down at the base of the stem, and oftentimes, if you can sever the plant below that meristematic stem, you'll kill the plant. So the effects of mowing is pretty dramatic on some of these vegetation, and again, the emphasis here is knowing the plants that you're treating and knowing a little something about the plants that you're dealing with. When you look at the long-term effects of mowing, you're dealing with monoculture, less structured diversity, and of course, your possible loss of seed production. All right, the third management technique I want to talk about is herbicide application. As a manager and starting off on the Goodwin area, man, I resisted herbicide application. I did not want to go down that pathway because I knew once you go down that pathway, there's no turning back. And I fought it and I resisted it, and that was the single most thing that I regret about managing that marsh down there. But there was a kind of a good thing in that too, in that it forced me to learn a lot more about other techniques to be applied and know what's effective and know what can work and what can possibly work. But when we think about herbicide application and the benefits of herbicide application, it definitely lends itself to a major advantage, particularly in our situation because we were dealing with an exotic grass called paraggrass. So the next series of slides I'm going to show you are kind of going to deal with how we dealt with paraggrass. But briefly, let me give you an introduction to paraggrass for those of you. Most of you guys, I see you've done a lot of hunting on Goodwin or are familiar with paraggrass. You know a little bit about it. It's a very invasive exotic. It's a Category 1 exotic, and no, that is not a typo. That is an agricultural pest in over 34 countries. It is widely distributed. It comes from the equatorial zones of Africa. And one of the reasons why it's so invasive is because it's been identified as a C4 or C3 plant. And it has this special ability to take up carbon dioxide. Again, getting back to that plant biology, carbon dioxide has a special ability to take up carbon dioxide much greater than our native plants. Why is that? Well, if you think about where it comes from, it's from the equatorial zone where you have 12 hours of daylight and 12 hours of darkness. And those stem cells and those cells are adapted to dealing with long durations of taking in carbon dioxide. And when you introduce this plant up here, it's like a plant on steroids, man. It just runs over everything. So it's a major issue. Fortunately for us, paraggrass doesn't produce a viable seed, and its primary form of reproduction is through rhizomes and stolons. It is very difficult to burn, even under the best, in this case what I mean the best or the worst conditions, and unless you've got extremely low humidities and high winds, that's really about the only time you can burn paraggrass, but trying to get a permit from the Division of Forestry to burn under those conditions is very rare. It is susceptible to top freeze, so you can run in and run a fire after a freeze and get pretty good control over those top stems and burn that off. But going back to the plant biology thing, remember that plant throughout the growing season has been absorbing a lot of those carbohydrates, and it's storing those carbohydrates in the news. And you can run a burn and you think, oh wow, this is great. We've gotten rid of this plant, we've taken care of it, but 2 weeks later the first summer rains come in and man, that thing just starts growing and starts reproducing all over again. You can also go in there and disc after you burn. You wait for that plant to grow up and throw up those first new leaves or shoots, you know, once it starts producing the first 6 or 7 leaf stage. And you know that once the plant gets to that stage, it really hasn't developed enough to start replenishing those carbohydrate cycles. But if you can go in there and do some disking and things like that to turn it over, that is a pretty effective control. We don't get as long-lasting of an effect on it as we do if we apply a herbicide with it, but it's, again, falling back on some of those techniques and some of those basic biological principles help you. Anyhow, so we broke down, we started using herbicide application, and it's made a big difference for us on helping us control paragras. And keep your eye on these 2 fence posts here. This is I believe it's impoundment 3 or maybe impoundment 4 on Lower Goodwin. Everything that you see here in the background, so we're standing, you're kind of looking northwest. This is 160 acres, it's solid paragras. We came in the fall, we applied herbicide. We waited about, I don't know, 6 to 8 weeks before it browns up, and the temptation is to go in there and burn this stuff now, but you really can't. You got to wait, because paragras produces stems about as thick as your finger, and it holds a lot of moisture, and you think you can get a good burn in it, but you really don't. So the longer you can let it sit there, and then the longer you can let it dry out, the much better burn you have. So we waited about 2 to 3 months. In fact, I don't think we burned this until early spring, maybe late winter, early spring. Got a pretty good burn on it. And then we immediately followed that up with a flooding. And this is what it looked like within, I don't know, a couple of weeks after we flooded it in the springtime. And here we are again later in the fall. These other grasses that you see is not paragras in the foreground, but we get a lot of moist soil annuals. The idea here is applying multiple techniques. We're using water level, we're using controlled burning, we're using chemical applications, and oftentimes that's what it takes to get some good effect. When we go through this process here, that we get about 3 to 4 years of really good production out of this impoundment before that paragras starts coming back in, and it creeps in from the sides, it comes in from these levees, and it's the damnedest plant I've ever seen. You know, it'll put out these long stolons, and those stolons will run out 10, 15, 20 feet, and it just starts going at it. So anyhow, so chemical application can be a really good thing. And finally, the last management technique I want to touch in and talk about is controlled burning. When we look at controlled burning, we can primarily on moist soil wetlands or, you know, isolated wetlands, we can break it down into 4 main groups. We're either initiating controlled burning to control exotics, setting back plant succession, increasing interspersion of open water habitat, and or seed bed preparation. We talk about controlling exotics and noxious plants, 2 primarily plants that we deal with besides the paragras issue that we just talked about, and that is cattails and primrose willow. There are 3 different types of species of cattails here in Florida. All of them are very prolific seed producers. In fact, a single cattail stem can produce anywhere from 200,000 to 300,000 seeds per stem. That's a lot, and they can remain viable in the soil for up to 100 years. Something to keep in mind, and getting back to that basic biological planting stuff, is this energy for initiating shoot growth. Is it aerobic or is it anaerobic? If we think about controlling cattails, a couple of things to keep in mind is controlling that to this annual cycle of this carbohydrate storage. Burn when carbohydrate reserves are the lowest. Again, we know that when the plant is starting off in the growing season, pulling those carbohydrates to start development. We also know that another weakness of the plant, or another weak period, is when the cattail's going into that flowering stage, is pulling up those energy reserves to produce that flower. We can burn to eliminate aerobic conditions, forcing the plant to convert starches under anaerobic conditions. This is critical. I mean, this is a huge step right here in gaining control of cattails. Cattails have these aurechma cells in them, which they essentially act as a giant snorkel. And this conversion of starches to aerobic versus anaerobic, it's all hinges on this and these aurechma cells. So If it's anaerobic conditions, obviously it's under the presence of water, and you look out on this pond and you see, well, hell, the conversion of starches is anaerobic. It's got 4 feet of water on it. But is it really? When you think about these erythema cells, and these, essentially they act as giant snorkels, that whole time you're thinking it's anaerobic, but no, it's aerobic. And the conversion of starches, under whether it's aerobic or anaerobic, it's much more efficient under aerobic conditions. So when we think about controlling cattails, we need to get rid of those stems. We need to top kill it. We need to mow it. Whatever we can do to get rid of those stems. When I was up in Canada about 10 or 15 years ago, looking at some of the wetland marshes up there, some of the biologists with Ducks Unlimited were telling me about how they do cattail control. And they actually, in the wintertime, they'll run a tractor over a frozen pond with a mower. And it's like, what in the world are these guys doing? Well, what they're doing is they're mowing the tops off of these cattails, and when the pond thaws off, it floods up just enough to overtop those cattails, and that's how they get a lot of control over their cattails. Another issue that we're dealing with is primrose willow. There are two primary species that we're dealing with is Leptocarpa and Perviana. It's a perennial shrub. It forms monotypic stands, and it's a very, very heavy prolific seed producer. Each little pod on a primrose willow, this is a pod that we broke open, it's literally hundreds and hundreds of seeds in there, little tiny things. So it forms very dense monotypic stands. It makes it difficult to get a fire through there because it's so dense you don't get a lot of fine dead fuels growing up underneath it. So when we think about control efforts, we're thinking about running out there and using a roller chopper. Again, multiple techniques here. You can run a roller chopper over it, mow it down, let it lay down, and give it about 2 to 3 months, and then you can run a cool little fire through there. And those fine dead seeds burn up very quickly, and it's generally a hot enough fire that you can burn it and pretty much eliminate any issues with that. Another purpose for controlled burning is setting back plant succession. Here we're targeting those perennial species. Remember the plants that we don't want in these freshwater marshes. This is primarily your woody stem species, such as your loblolly bays, your wax myrtles, your willows, saltbush. Here we know that saltbush flowers in the fall, willows flower in the spring. Another thing to keep in mind when you're thinking about your efforts, your control efforts, and thinking about carbohydrate reserves and all. Control measures, time it to when the plants are most stressed, as in during those flowering periods. If you can run a fire through the growing season when you get higher elevated temperatures on top of the fact that you're burning when the plant's already stressed already, you can achieve some pretty good results. One thing to keep in mind is willows. We know willows have this coppice root system. They're easy to burn and they're easy to kill, top kill, but this coppice root system comes into effect and you get all these runners shooting up, and this is a classic example, so keep that in the back of your mind as well. We're winding down here. I only got a couple more techniques to talk about. The third one is increased interspersion of open water habitat. This is one of my favorite things to do when we're out there and we're managing marshes. It's the fall and the weather's just right and you're getting all amped because you know your birds are coming through, and here we have this beautiful impoundment, and I don't know if you can see all this white stuff here, but that's smart weeds. It's like duck candy, and you think, wow, this is great, all we got to do is add water. But the problem here, if we add 12 inches of water, that grass is, knee high, and if we flood it to 12 to 14 inches, you won't have a single duck in there. It doesn't do anything. We need to provide some open water habitat. We got to figure out a way, how do we go in there and open it up? We can draw it down, we can chop it. There's a bunch of different techniques, but then there's also this technique of using controlled burning. And so when we talk about using controlled burns and helping us increase this interspersion of open water habitat, it's a short-term cosmetic technique. We use this in areas where you have these fine dead fuels or these fine fuels that will help carry your fire through. And the idea is not to do a complete burn. So if those of you guys have done controlled burning and you got your torch, you don't want to carry a torch all the way across it. You just want to do some little spot treatments here. And the idea is running in through this marsh and having these little burned out areas like so. And then you follow that up with a burn. And then you follow that up with some flooding. And the idea here is that these open water areas kind of represent those areas that you burn, and you get this beautiful mosaic of habitat of open water areas intermixed with all this food resources, and you got lots of ducks, and that's a pretty cool thing. And lastly, we use controlled burning. Probably the least amount is in seed bed preparation. Again, the situation here is you have an impoundment, you're trying to decide, well, I'll be better off disking or roller chopping. You know that it's going to take you about 2.5 to 3 days to go in and disc that and probably burn about 300 gallons of fuel. Is it possible? Would this situation warrant a burn as opposed to burning or chopping or disking? You bet, it sure can. And in those kind of conditions, it can be a lot more economical and much cheaper than mechanical manipulations and just as effective. So we use this technique during the late winter when you have these cold fronts coming in, where you have these cool, consistent winds that allow you to run a backfire through there. And the thing about a nice, cool burning backfires is that consumes a lot of the plant biomass. And so you have this nice, clean, charred area, and this allows sunlight penetration, and that allows the germination of these moist soil annuals, and it starts that cycle all over again. So, quickly, in summary, know your plants. Know your plants. Know something about the plants you're treating. Know something about what you're trying to get rid of and what you're trying to encourage. Do a little history and look at the information about that plant. Know when it flowers, how it flowers, those kind of things, and disturbance. We cannot emphasize disturbance enough. Limit your exotics and your perennials. Consider multiple treatments, and it all begins with water level manipulation. You've got to have your water level manipulation. And be patient. Anyhow, that wraps up what I have, and I'll be glad if we have time to take any questions.
We have about 7 minutes, so feel free to ask questions.
Manipulations. Ran cows for a while in Goodwood.
Yeah.
Do we still recommend use of that type of technique? Did you positives, negatives to something like that?
I'm glad you asked that question because I meant to cover that. So Ron asked about manipulations and whether or not cattle grazing is a possibility. And we first looked at cattle grazing on Goodwin area to help us gain some control over that parag grass. We know that parag grass was brought in for grazing, and we kind of had this idea, well, if cows like it, why don't we bring cows in? We know cows are very good for freshwater wetlands in the sense that they create a lot of disturbance and they can consume a lot of plant material. And if you've got a lot of grasses that you want to get rid of, such as parag grass, why not bring cattle in? Bring cattle in during the growing season, and then we can rotate them off during the wintering season and flood these impoundments up. So that was a theory that we applied as a measure of control for the parag grass. So we bring in the cows during the growing season, we let them eat all the parag grass, and we pull the cows off, and then we flood those up, and we have good hunts. And then on top of that, we looked at cattle grazing and the application of herbicide to help us gain control. And it was very effective. The more grazing that you implemented, the better control you had, the more diversity of plants that came in afterwards. The problem with it is that we own the land, and as we're not cattle ranchers, and it takes a lot of grazing to get that effect that you are looking for. As a waterfowl biologist, we were looking for high intensity grazing, and it takes a lot of management of your herd to do those kinds of things. So high intensity grazing is a short duration. You bring them in, you let them graze it, then you get them off, and then you bring them back 3 weeks later, and that has more of effect on your vegetation than anything. But yes, cattle grazing in the marshes can be effective.
A decade ago, we would have flocks of literally tens of thousands of ducks on the tidal estuaries. We've lost most of our seagrass meadows, particularly in the Cruise Hatch. Would you talk a little bit about management of submerged aquatic vegetation and how that fits into the overall scheme of things?
I didn't understand the first part. Were you talking about in estuaries or in freshwater areas?
No, it's estuary. It's our brackish areas, you know, in
Yeah.
And we used to have, 10,000 scalp, now we've got, they come in, they'll stay for a day, but they fed on those, Bellison area and on the brackish water stuff. They're gone.
You know, I'm not really, to be honest with you, I don't know what the issue is. I was talking to several folks last night about, are you talking about specifically in the Indian River Lagoon? And
Both sides, but I focus primarily on the Caloosahatchee. We've lost virtually all of
Yeah.
the grass in the Caloosahatchee.
Well, I know in the Indian River Lagoon, it's you're looking at those submerged seagrass beds are critical, and more importantly, we got waterfowl that are not only feeding on those seagrasses. Halidule is a primary species that they feed on, but we also know that they feed on a lot of pelecypods associated with those seagrasses. In the Indian River Lagoon, it's an anomaly what we're experiencing there right now. We've had some problems with some algae blooms in the last 3 or 4 years that has had an effect on those seagrass beds, and I suspect as a result of that, you don't have the bivalves in there, your pelecypods in there that they're keying in on. I know in the Panhandle region, you get out into the Gulf coastal waters, 4, 5, 6, 7, 8, 10 miles out in that shallow water zone where those halidule grasses are. That is a primary diet for redheads out in there. As far as specifically what's going on in the Caloosahatchee with the seagrass beds, I'm not really familiar. Maybe somebody else here in the audience has a little bit better key in on that. Anybody here familiar with seagrass beds in Caloosahatchee area? I suspect that, there's always issues dealing with water quality issues, algae issues. We get these algae blooms and they have to run their course and they have an effect on seagrasses. But that's the best I can give you on that one. You bet. Mark.
Have, I guess, managers or folks like dealing with Goodwin and managers that deal with those types of impoundments, are you having pushback from the water quality regulators? Because I agree with you, disturbance is the key to success, but disturbance can also lead to water quality issues with release of nutrients when you do those disturbances. And I'm wondering if that has started to enter your realm of discussions with what you guys are doing.
Well, I think it's always an issue that people are concerned with, and one of the first things that we started doing is this is way back probably 15 years ago when we started introducing a lot of disturbance on those moist soil impoundments on Goodwin. We worked with St. John staff and did a geomorphological study, and we looked at different management techniques and their effects on nutrients. And what we found is Lawrence Keenan is a fellow we dealt with, and I think he's still with the district. What we found is about 6 to 8 weeks after that disturbance has been implemented, that your flux of nutrients shoots way up. But when you think about when you're implementing these management techniques, you're drawing these impoundments down, you're implementing a technique to encourage certain plants to grow, and so when you flood that impoundment up, you're not going to turn around and get rid of it. You're flooding that impoundment up to manage those wetlands. And so, yes, there is a flux of nutrients. That flux of nutrients all but disappears after about 6 to 8 weeks. It is virtually gone because those plants absorb it up. So the concern in this case would be if you're implementing a management technique and if you're going to flood that area afterwards, we won't want to see any water releases within that 6 to 8 week periods. Otherwise, we're just flushing all those nutrients downstreams. But for our effect and for what we're trying to achieve, that's the last thing we want to do is get rid of that water. We want to keep it. So, but a valid point. I'm glad you brought it up.
Steve, how's that progress get there to begin with?
It was brought in. That area, the Goodwin area, was diked and drained for cattle production, and we know that they brought in paragrass, stargrass, and Bermuda grass.
Before they started to develop it then?
Yeah, yeah. It was always there. I'm the first to admit, I'm probably heard it. I probably did more to produce more paragrass because of some of the treatments we were applying. Again, if you think about what we're trying to achieve there, it's all about moist soil annuals and managing for grasses. So a lot of the techniques are beneficial to grasses, and unbeknownst to me, and I'm out there disking it, and every time I disc it, paragrass reproduces. Again, getting back to your basic biology, Parrotgrass reproduces by rhizomes and stolons, and you go out there and you take a rhizome and you cut it into 3 different pieces, guess what? You got 3 new plants just starting out. So I was out there disking and chopping and doing all these things, thinking I was doing these wonderful things and getting duck food in there, and oftentimes I was producing more parrotgrass. But, yeah.